Okay, last but not least, we're going to talk about the graph of secant. That's going to be our topic 4 for this worksheet. So we're just going to kind of dive in. All right, so we're talking about the graph of y equals secant x. You could also have f of x equals secant x. Remember that x is an angle along, we're going to, we're going to have a regular x-axis. We're going to break it down into radian measures. And then y is going to be the ratio that secant spits out. Okay? Now, some things that we need to know about secant before we dive into this graph. Number one, secant is periodic just like the other trig functions, and it has a period of 2 pi. So every 2 pi radians, you're going to see repetition. You're going to see this graph cycle again. Okay, secant is the reciprocal of cosine. So you need to be familiar with the graph of cosine before you dive into secant. Okay. Now, when we were talking about domain and range of trig functions back in 7.5, we acknowledged that there were going to be issues with with secant. We knew that if the denominator, which is cosines, like if we're talking about this right here, if we're looking at the ratio for secant, it's 1 over cosine. So if we ever have a situation where cosine is 0, we're going to have a situation where secant is then undefined, okay? And so we asked ourselves, well, when is cosine equal to 0, okay? Well, we found that cosine was equal to 0 at odd integer multiples of pi over 2, okay? So we need to know how to write that domain. So we would say, okay, the domain is x. So we can now say x because we're looking at the regular old x-axis. We're just breaking it into radians. So we're saying x such that x is not. Okay, how do we tell our reader that we can't be odd integer multiples of pi over 2? Well, we start with pi over 2. And what we found is if we go from pi over 2 and we go an additional pi radians, we end up at 3 pi over 2. And then pi radians again, we end up at 5 pi over 2. And then pi radians again, we end up at 7 pi over 2. So essentially, we're multiplying cycles of pi, okay? So the way we do that is we say it's pi over 2 plus k pi. That's a problem. So x cannot be pi over 2 plus k pi. And then we just had to make sure to tell our reader, hey, guess what? K is an element of the integers. So we use that weird notation, okay? And what we found, hopefully you're aware of this now, but we found that those domain restrictions, those odd integer multiples of pi, those occur when cosine is equal to 0. Okay, so when the cosine function has an x-intercept, meaning cosine equals 0, the secant function has a vertical asymptote, okay? So when we have cosine equals 0, that means an x-intercept for cosine, we end up getting a vertical asymptote. So what we're going to do now is we're going to jump over to a separate document so I can show you how to build the secant function. And basically we start with cosine and then we kind of build. This is going to look very, very similar to cosecant. It's just shifted, okay? So let's go over to a different document. So we have our graph of cosecant. Let's scroll down and start over with a graph of secant. Okay, so we're going to draw an x-axis. And remember, we're going to break our x-axis into radian measures. We have a y-axis. We're going to say this is pi over 2. That makes this pi. This is going to be 3 pi over 2, which makes this 2 pi. We'll say this is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay? And then we'll say we're going to go 1, 2, 1, 2. Okay? Now, when you're dealing with cosine, we have those 5 key points. Okay? So remember, the 5 key points are the ends and center of the graph. So the beginning, the end, and the center. So ends and center. And then you have the quarters. Okay? And you're either going to have x-intercepts or peaks and valleys at the quarters, and then you're going to have the opposite at the ends and center. And what we need to remember is that cosine has a y-intercept of 0, 1. So that tells me right off the bat that the beginning of this graph is a max. So my x-intercepts are going to be at the quarters, and the peaks and valleys are going to be at the ends and center. Okay? So with that said, let's keep plotting here, okay? So we have the start of our period at 0, the end of our period at 2 pi, because cosine has a period of 2 pi. The center is at pi, and then the first quarter is at pi over 2. The second quarter is 3 pi over 2. So we've split our period into 4 equal regions, and we have 5 key points, okay? Now, because of our y-intercept being a max, we know that our x-intercepts are going to be at the quarters. So I'm going to have an x-intercept here and here. And then we always alternate max, min, max, min, max, min. So if this is a max at the beginning of the graph, so at the first end of the graph, then the center is going to be a min. So we're going to get pi negative 1. And then 2 pi, we're going to be back to a max. Okay? So if we were to draw one cycle of pi, I'm going to do the dotted lines again. We would get that. And just know it keeps going. Okay, now we could do the same thing for the left-hand side of the graph. So we would have x-intercepts at negative pi over 2 and negative 3 pi over 2. We would have a, let's see, we're going to go down. So we would have a min at negative pi and a max at 2 pi. So that is a sketch of cosine. And remember, you're not graphing cosine, you're graphing secant. So we just want a sketch of cosine. And then we acknowledge that we're going to have vertical asymptotes wherever cosine is 0. So wherever we have an x-intercept for cosine, we're going to have a vertical asymptote. So we have a vertical asymptote here, 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 and then technically over here, even though it's getting shoved off the graph. Okay, so we have our x-intercepts as vertical, so our x-intercepts of cosine are the vertical asymptotes for secant. So let's go ahead and draw in our secant curve. So remember, the max and min of cosine is going to be a max, or not a max or a min, but it's going to be a point on the graph of secant. So we know this is a point on the graph of secant, and then we just draw our curves. This is a point on secant, and we draw our curves. This is a point on secant, so we have room to draw half of our curve. This is a point on secant, so we have our curves and secant. So there's the graph of secant. And again, if I were to scroll up and show you cosecant, they almost look identical. It's just where the peaks and the valleys are, okay? That's really the only difference, okay? So there's secant and cosecant, all right? So let's go back to the original document and do a transformation on secant, okay? So, and there's the official graph, all right? So just like with cosecant, we're gonna graph transformations of secant, but we're gonna start with like the reciprocal function. We know how to graph sine and cosine. Those are pretty easy. So when you're graphing a secant graph, start by graphing like the same graph, just replace secant with cosine. So what we're gonna do is we're gonna start with y equals 2 cosine of 1/2 x. Okay, so in this case, a, the coefficient, like the number that's multiplied by pi, it's positive, so we are not reflecting about the x-axis. Okay, so we don't have a reflection, but we do have an amplitude. So amplitude is the absolute value of 2 or just 2, so that's going to stretch our graph. Okay. And then we need to talk about the period, okay? So we have omega here is 1/2. So we definitely have a horizontal stretch or a compression, all right? So we need to figure out how that impacts our period. So the period of our graph is always going to be the initial period. So the initial period is 2 pi. And then we're going to divide by omega, which is 1/2. So we get 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. So our period is 4 pi. So let's look at the important points. So the beginning of our period is at 0 and the end is at 4 pi. Okay? We need to break that into 4 equal sized pieces. So halfway between 0 and 4 pi is 2 pi. Halfway between 0 and 2 pi is our first quarter. And then halfway between 2 pi and 4 pi is our second quarter. So those are our important points. And we have to remember we're graphing a sketch of cosine, okay? Cosine has a max or a min at the ends and the center, and then it has an x-intercept at the quarters, okay? So we've got an x-intercept here and here, and then we're not reflecting, so we have a max at 1. So we need to do, well, we'll do the max and min in a second. I was about to screw it up for you. Okay, so we've got our x-intercepts. Now at the ends in the center, we have our maxes and our mins. And remember, our max is going to be starting at 0, and then the initial max is 1. But remember, we have to multiply our max by our amplitude. So our new max is going to be 0, 2. Our center is at 2 pi, and the initial min, we would go max min. So the initial min is -1, but we have to multiply that by 2. So that makes our new min at 2 pi comma -2. And then our second max would have been at 4 pi. And the max initially would be 1, so we multiply 1 by 2, and we get our max now is at 4 pi comma 2. So we would plot here, here, and here. So remember, we're just sketching, okay? And then let's mimic that on the left-hand side of the graph. So we would have an x-intercept here and here, and then min here, there. So now we can put in our secant curves, okay? So remember, we're technically graphing secant. We're not actually graphing cosine. We're just using that as our guide. So we know that anywhere cosine is 0, we're going to have, that's where we have x-intercepts on cosine. We're going to have a vertical asymptote. So let's plug those in real fast. And then we can put our curves in. And remember, the max and min on cosine are going to share a point with the secant graph. Okay, so we would have a curve here, 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 and we have enough room for half here. Okay, so that is the graph of y equals 2 times secant of 1/2 x. Okay, so technically the dotted cosine graph shouldn't be there, but we're going to keep it just so you can see it as a guideline. Okay, so that is graphing tangent, cotangent, secant, and cosecant. Okay, our main focus is going to be sine and cosine, but understand these, especially so you can understand the domain and the range. Okay.